In this video, we're going to take a look at a properly charged, properly operating air conditioning system, and then we're going to throw an overcharge on it and see what it does to the pressures, the superheating, and subcooling. So let's get started. Let's first pop into the thermostat, make sure that our thermostat is on. Then we'll go to the indoor unit. We can hear it running there. Let's take the cover off and see what kind of metering device we have. And we have a fixed orifice system here. We don't have a TXV. So that's one thing that you're going to need to check before you do any system pressure measurements. Alright, let's go to the outdoor unit. So it's operating. We've got our warm air coming out of the top. So we'll get our gauges out. We'll throw them on. Take a look at superheat and subcooling, and then we're going to overcharge it. So we'll get out our testo gauges because we don't have to go back and forth to our PT chart. So we'll put the high side gauge, our high side gauge hose on the high side. We have our temperature probe right here. Low side here. So this is an R22 system. We're running 243 psig. At the condenser and 70 psig at the evaporator. The one thing I want you to remember, even though you're measuring the pressures right here, I want you to picture in your head when you look at this 243 psig that this is the representative of what's happening exactly in the center of the condenser coil. And the 70 psig, I want you to transport yourself into the evaporator coil, and that is taking a snapshot of what's happening on the inside of the evaporator coil. And then when you have your temperature probes and look at those are measuring the physical temperature right here. So even though these hoses and the temperature probes are close together, these hoses are actually telling you what's happening in the center of both of the coils. Okay, so 243 psig on the high side, 70 psig on the low, and we have a nice superheat of 13 degrees. And a nice subcooling of 13 degrees, 40 degree coil temperature inside, 115 degree coil temperature outside. So everything's operating properly. Remember, this is a fixed metering device, so what do you think is going to happen if we overcharge this system? Here we go. So let's start adding some refrigerant. Let's take that back out and we'll start again. Let's add a little refrigerant. Now, if this isn't going to happen immediately, but on a real system it's going to take 5 or 10 minutes for these pressures to stabilize. But look what happened. We went from 13 degrees of superheat. If we overcharge the system, superheat decreases down to 2 degrees. You see that? We go from 13 to 2. So let's take it back out. What happens to the subcooling? It goes from 13 to 22 when the system is overcharged. So what's happening is the subcooling is going up because we have refrigerant backing up into the condenser coil here, and it's spending more time in the condenser coil than it should, so it's picking up more subcooling. And then we're start beginning to flood the evaporator on the indoor coil, and it's not able to pick up as much superheat as it should. So let's go back. 13 and 13 again. Look what happens to the condenser pressure and temperatures as we add refrigerant. The pressures and temperature goes up. Look what happens to the low side when you add more refrigerant. Those pressures and temperatures go up. So as you add refrigerant and you overcharge a system, subcooling increases, high side pressure increases, superheat decreases, and the low side pressure increases. So, you know, if you're new to HVAC and you think that adding refrigerant makes things run better and run colder, that is not the fact. So we can't add any more refrigerant to that, but you can see what happens when we overcharge a properly operating system. All right, one more time. We'll go through it one more time so you get this. Here we are, properly charged, good superheat and subcooling levels, and we overcharge the system. Subcooling increases, system pressures and temperatures increases on both sides, and our superheat decreases. That's what an overcharged system looks like.